Hello, and thanks for joining this session. My name is Kenji Kazumura, and today I will talk how to scale your microprofile application in the Kubernetes environment with MicroProfile Metrics. Today's agenda, at first, I will talk about cloud native and scalability as the motivation of this session. And I will introduce Kubernetes Autoscaler, which is some component of Kubernetes, and introduce briefly MicroProfile Metrics, which is a standard specification to handle the metrics with Java language. And finally, I will show you some demo to integrate the MicroProfile Metrics with Kubernetes Autoscaler. So let me introduce myself. My name is Ken Kazumura, and I'm working for Fujitsu. And Fujitsu provides Jakarta E10 compatible product and also provide MicroProfile 5 compatible implementation, which is called Launcher. And Fujitsu is a strategic member of Jakarta E working group and also a corporate member of MicroProfile. And I am several committee member of this working group. So this is the definition of cloud native defined by CNCF. And I think most of you know this sentence, and most of you have read many times, so you know what is cloud native. But today, I focus two things, scalability, scalable application, and containers. So the main purpose of scalability is to keep the performance healthy, depends on your workload. But I think scalability is also useful from the viewpoint of energy consumption or sustainability. Jevons paradox is originally described about coal fuel resources. So if the technology improves the coal fuel usage, you may think the demand will decrease. But in reality, the demand is increased. So I think it is also true about computational resources or cloud resources. So we should consider these kind of resources because these kind of resources are unlimited. Of course, the scalability does not resolve this problem entirely, but I think scalability mitigates this problem. So this is the steps to build up the scalability systems. I simplify just 4 steps. The first one is to define the metrics to use for scale and define the threshold when you scale or not. And this step is deeply depends on your application. Step 2 is to export the metrics that you defined at step 1. But in some environments, some of the metrics are automatically exported. For example, if you use Kubernetes, the CPU and memory usage are automatically exported. Step 3 is monitor the metrics defined at step 1. And step 4 is scale your system, such as VMs, container, or application. And the point is step 3 and step 4. So usually step 3 and step 4 are required to be automated because no one wants to monitor the metrics with your own eye, or no one wants to scale your system by hand. But don't worry about it. If you use Kubernetes, Kubernetes takes care of step 3 and step 4. And Kubernetes Autoscaler takes care such step 3 and step 4. So I think many of you know about Kubernetes, so I don't need to explain the detail of Kubernetes. But Kubernetes is a de facto standard of container orchestration tool. And you can use it in your own infrastructure, such as on-premise. And also you can use it in the public cloud as a managed service, such as AKS or EKS. And Kubernetes provides an automatic scaling method. So you don't need to prepare another tool to scale your systems when you use Kubernetes. So these are steps to build up the scalable system with Kubernetes. These steps are almost the same as one I mentioned before. But what you need to do is only step one. Kubernetes take care of the rest of 3 steps. But be careful, step 2. Kubernetes can only handle the node or port related metrics. So if you want to use other type of metrics, you need to do by yourself. And generally, there are 2 types of scaling. The one is vertical scale, and the other one is horizontal scale. And Kubernetes provides both types of scaling mechanisms. And vertical scale is like this, and it does not change the number of ports. Instead, it changes the number of CPU or size of memories. On the other hand, horizontal scale does not change the size of memory or number of CPU. Instead, it changes number of ports. So question here is which scaling mechanism should I use? The answer is it depends on your application, so you need to consider the pros and cons of both types of scale. Kubernetes provides both types of scale, vertical pod autoscaler, VPA, and horizontal pod autoscaler, HPA. The pros of VPA is you don't need to consider the special application design. That is, you can use your existing application as it is. The cons of VPA is less reliable than HPA. Because if the number of ports is 1, so if this port is crashed, the entire system is also crashed. On the other hand, when you use horizontal scale, even if some of ports are crashed, the entire system can be alive with a living port. And cons of HPA is you need to design your application to work with multiple port instance. For example, your application should be stateless, or your application should not rely on the session features. Today, I just use HPA, but usage of VPA is almost same as HPA. So this is a diagram of HPA system. In the middle, there is API server, which is a component of Kubernetes. And it's a sort of front end and to communicate to other Kubernetes components. And in there is a metrics API. And you can access metrics API like this URL. But if you want to access this metrics API, you need another component of Kubernetes. That is metrics server. Metrics server collects the metrics from port and send them to the API server. Then HPA read this information and scale your systems. So let's see the example of metrics servers. So this list is component of this system. So you can see API server here, and metric server is here. So you can access the metric API. To access metric API, you use this command, get command, and specify row and URL. So there are two resources, node and pod. So the metrics API can handle only two nodes. And if you want to see the pod metrics, and put pod, and there are a lot of information, so so you can see the information about Hello app pod. I already deployed Hello pod here, and the metrics information is here. So you can see only CPU and memory information. So make sure that the metrics of CPU and memory can be recognized with this kind of Kubernetes dashboard. So the metrics API only handle the CPU and memory information. But if we want to use other type of metrics, the using MicroProfile Metrics is one of the best way. So, and many of you know about MicroProfile Metrics. I just briefly introduce MicroProfile Metrics. MP metrics export the metric data, as known as telemetry. And it also provides special access endpoint. Like this, /metrics. And MP metrics provides three types of metrics, base and application and vendor specs. But today, I am only interested in application metrics. And MP metrics also provides Java API, and you can export your own application data using this API. And let's see the example of MP metrics. And this is a typical Jakarta RESTful web service. So you can access this application with this endpoint. And metrics API is here. I use counter variable, and I named it login counter. So please remember this name. And this application called login service, but actually it does not anything about login procedure, just increment counter or decrement counter for just demo. Yeah. And this application provides two endpoints, login and logout. If you access to the login, the counter is incremented and returns to the response with the current counter value. And when you access logout endpoint, the counter is decremented, and the same as before, the message returned with current counter value. So this is a sample program. And to run this program, you need MicroProfile implementation. So today I use Launcher, which is a MicroProfile 5 implementation. You can download it from GitHub repository. So I already built up this application as a WAR file, HPA01 WAR. So to run this program very easy, to invoke Java and specify the launcher module and specify the application. That's all. And to access this application, car localhost, the default port is 8080, and EclipseCon login. So you can see the current value. And again, login, the current value is incremented. And if you access the logout, the value is decremented. So if you want to see the metrics of this variable, you specify the special endpoint, metrics and application, because I am only interested in application metrics. So you can see here is the output of metrics. So remember that this name is the metrics name I named in the source code before. And application means MP metrics application. And the value is 2. And if you access again, login, the metrics also change to the new value. Okay, this is MP metrics. So now I will show some demonstration, integrate MP metrics with Kubernetes HPA. So this HPA scenario, there are two types of scenario. The top one is when using default API server and default metrics server. The bottom one is using external API and MP metrics. For example, the customer log into some system and then do some work, such as shopping or payment, whatever. And after that, CPU or memory usage increase, then your system will be scaled. And the bottom line is another type of scale using external API. At first, customer log into the system. And in this time, the number of login user is incremented. So you can scale your system in this time. And after that, the customer do some work. So by using external API and MP metrics, you can change the timing of scale from here to here. So this is just an example. So maybe another example is you can use number of connection pool to the database. So next slide is HPA system with MP metrics. This diagram is also almost same as before. But still there is API server, but there are new metrics API that is called external API. And to use this external API, you need to additional component. So today I use Prometheus adapter to create this external API. And I also use Prometheus server. And Prometheus server collects the metrics from the pod. And Prometheus adapter reads the metrics information from Prometheus server and send them to the API server. And HPA read this external information and scale your systems. So these are steps to build up the HPA system. There are 3 steps. Step 1 is create your application and deploy to the Kubernetes and set scraping information. So first step is this portion. So I use same application to demonstrate. at first, I need to create the Docker image. And in this Docker file, very simple. Copy launcher module, and copy application, and invoke Java. And build the image. And next, I deploy this Docker image to the Kubernetes to use this YAML file. So I create a deployment, and the point is here. I set the configuration to the Prometheus. So I set true to the script, and I set this endpoint for the path, because I am only interested in application metrics. And I also create the node port service, and to access outside of the Kubernetes cluster. And the port is 380. So I deploy this application. And you can access this application like this. This IP address is a node host because I use a node port service. And login. Yeah, the result is same as before. The counter is incremented. And if we want to see the metrics, I use other tools, Prometheus dashboard. So you can select the application metrics name. Where is it? Application, yeah. So this is the MP metrics name, login counter, and execute. And you can see the current current value of metrics. And again, you access to login. And you can exit new values. So step 1 is completed. And step 2 is create the external API with using Prometheus adapter. Step is here, Prometheus adapter setting, and create external API. To create external API, you need to set the configuration like this. And I use Helm upgrade to specify this configuration. This configuration is very simple, but the point is there need to specify 2 names. One is here. This is the MP metrics name, login counter. And a little bit complicated, but we need one more name here, EclipseCon external metrics. This is a name for external API. So a little bit complicated, but one name is here, the metrics, MP metrics name, and it is also, the other name is also needed for the external API. And this name and this name are different. So a little bit complicated, but please remember this name, EclipseCon external metrics, for the name of external API. So after creation of the external metric, you can see the value of external API. That's JSON. So you can see the metrics of external API. So you can see this name. Again, this name is not MP metrics name. And if you want to see the value of this metrics, add more things. Like this, specify name, space, and default, and external API name. And you can see here the value is 4 because current value is 4. So you can see other value. I access logout and logout. The current value is 2, and see what it will be changed. The also external API changed to 2. So now I can connect this metrics information and this metric information. So we are almost done. So third step is finally setting the HPA configuration. To create HPA, this is very simple. To specify HorizontalPodAutoscaler to the kind, and specify the target deployment. So in this time, I want to scale hello pod. I want to scale hello pod. And specify minimum replica number is 1, and max is set to 5. So you can scale from 1 pod to 5 pod. And you can set the metric information here. Type is external. And again, this name is not MP metrics. This name is external API metrics name. And I set a threshold to 3. This is a target. It is called target value, but it's a kind of threshold. So apply and create HPA. So to see the status of HPA, you put get command HPA. So unknown meaning is not ready yet. So again, this value 2 is the current value of metrics, and 3 is a target. This is a threshold. And this number is a current running pod. Make sure for now, the hello pod is only one hello pod is running. So, and access to, again, login and login. So current value is now 4. And see what will happen in the HPA. So you can see the value is changed from 2 to 4 because the metrics value is changed. And after a short time, more time is needed. Yeah. After a short time, the replica number is also changed from 1 to 2, so you can successfully scale the system. And be careful, this is the average. So the total number of metrics value is 4, but the replica number is 2, the average is 2. Again, so I log out, and one more log out. So total value is 2. And it takes time. Okay. The value is changed to 1. And after a short time, okay, the replica is not decreased. So yeah, successfully the scale in and scale out. Okay, wrap up. scalability is one of the most important key of cloud-native application. And Kubernetes provides two types of scaling mechanisms, VPA and HPA. And Kubernetes HPA, as default, only handle node and port-related information, such as CPU and memory. And in addition to that, HPA can handle the external API, such as MP metrics. So MP metrics is a standard specification to handle the metrics with Java language. And I show you some demonstration to integrate MP metrics with Kubernetes HPA. So I hope this session will liberate your cloud-native application with MP metrics. So that's all my presentation. Thank you very much. If I think 1 minute left, so if any question, yeah.
Yeah, I have a question. Thank you, great presentation and great demo. But could you please provide an example where the application metrics in the real world make sense? I mean, for me, it totally makes sense to scale based on the CPU and memory usage. When you set thresholds, for example, to 75% and spin up a pod. Login demo is great, but I mean, it's still the demo. One comment on autoscalers, it's a very hot topic, but autoscalers are not that great. So they're great for predictable workloads and like predictable and flat workloads. So for example, if you don't have spikes, for example, if you are using Alexa and you get up in the morning together with millions of people and they need to turn it off, there is a huge spike and you cannot rely on it autoscaler because it will basically will not be able to spin up it so quickly. So how they do it, they like spin up in advance, like 5 minutes before like a lot of machines. So wondering like when actually the application metric scaling makes sense in the real world scenario.
So actually, I don't know the real system, but yeah, I agree that for the spike situation, this system cannot be applied. But you can predict if the login number and the CPU increasing is some kind of relationship can be known beforehand. So you can use this type of systems.
Yeah. Good comment.
Yeah.
So you know in advance.
Yeah. Yes. Yeah.
Maybe WebSockets. WebSockets are stateful, so you don't want to have too many WebSocket connections to the same node. You see that you are reaching a certain number of connections, and you spawn another one, and future users will start going there.
Yeah. That makes sense. So yeah, it's great comment that you know like. That you know for sure that there will be like spike in CPU based on your application, but it didn't yet happen.
Yeah.
Just do it in advance. Yeah.
Okay. Thank you very much.